Hi and welcome back to the channel. I'm sorry for the wait, I've been quite busy, but let's get to it. So in the last video we set up the database, so if you didn't watch that one, I highly recommend that you do. In this video we're going to use GRDB, we're going to take advantage of concurrency and combine, and I'm going to show you two really important but different ways on how we can persist data with GRDB. So without further ado, let's move to Xcode. Okay, so the first thing that we have to do is to make our properties of our models match the columns of the tables in our database. And I have just some template model here. Let's check it out. You can see that the ID, we are going to provide the ID for the restaurant. So have this as not an optional and just keep it as a string. Same goes for the name, we are going to provide it. But you may have noticed some inconsistency here. So if you go back to the migration, you can see that the ID isn't specified as not nil, even though the model data, the property of our model isn't an optional. And why is that? The reason being is that there are some exceptions to this rule. And one of them is that the ID column will never be nil in the database. And that is why I haven't specified not nil here. But if you go to the name column or any other column nearly, I think timestamp also has the same exception. But if you go to the name here, you see that we have to specify this one as not nil because the property that we have, not in our dish, but in our restaurant, is not an optional as well. Okay, now let's move on to the dish. And the dish one is going to be different because we are not going to provide ID. So it should be, according to documentation, assigned integer of 64 bits. And since we are not providing it, should be an optional. And the dish, of course, has a foreign key. It should be a restaurant ID and it should be a string. And this one is super important that this one is not an optional. And the reason being is that it would be super weird if we had a dish be standing alone without a restaurant. With having this one as not an optional, we are saying that each dish has to belong to a particular restaurant. Like a restaurant can be standing alone can miss out on a certain dish, but a dish can't miss out on our restaurant. So this one should not be an optional. Okay. Now let's move back to the restaurant. And let's make our model data be able to communicate with GRDB. So the first thing that we want to do is to make our model be able to encode itself into a database row. So let's, for clarity, do an extension of the restaurant and add the encodable record protocol. And then we want our models to be able to decode themselves from a database row. So add the fetchable record protocol. And I guess why the name isn't decodable record is because it has more capabilities beyond just the decoding part itself. And later on, we will actually revisit those capabilities. Now you can notice that, or you notice that there are some implementation that we actually have to take care of here that comes with these two protocols. But if we actually add some more protocols, GRDB can take care of it for us. So let's move on to the source code and let me show you. So if you look at the source code here, you can actually see that with the encodable record, as long as our model data conforms to encodable, GRDB will take care of the encoding part here for us. And it's a lot of complicated code that we don't want to implement. And the same goes for the fetchable record too. If you see here, if our model data conforms to decodable, it will take the row and actually decode it for us. So let's move back. So all we have to do is just add the codable record protocol, do a command B, and it should compile. Awesome. Okay, now we want our models too. We want them to be enabled to build SQL queries with the Swift language instead of SQL. So to do that, we need to add conformance to the table record protocol. So just do an extension again, just to be a little bit clear. So do an extension to the table record. I'm actually going to open this up. And since we also have a more complicated query, because we have one query that involves both of our tables, So to actually build out that query, we need to define something called an association between them, which is from GRDB, which is just establishing the relationship between both of our tables, or you can say defining the connection between them. So to do that, you can go with static let dishes equal to, and what is the relationship that we have? It's that a restaurant has many dishes. So we are going to use the has many, and it's going to be dish.self. You see why this is a static soon. It will make sense very soon, but just follow along. So, but we also want to fetch that data too. So to actually fetch that data, we need something called a fetch request, which is just a type in GRDB that fetches and decodes database rows. And there are two main kinds of fetch requests. You have the SQL request and the query interface request. So if you actually wanted, you could create a fetch request by writing SQL in. So you could mix up Swift and SQL and write a select statement inside that SQL request and create a fetch request from that. But since we're focusing on Swift, I am going to use, as you guessed it, the query interface request instead. So below here, define a property called dishes, and it's going to be of a query interface request. You can see here a request, maybe can just here a request that builds SQL queries with Swift. Okay, and we inside here you need to specify what we are getting from that request. So what are the records? It's going to be of type dish. And I think this is from the table record, but we have access to this method and it returns a request for the associated records, and that is what we want. And now we have this defined association here that we can use. And now it makes sense to use that it's static, because we can now go with saying here, we can say restaurant.dishes. So now we have a request for the associated records of a particular restaurant that we can later use to fetch the particular dishes for that particular restaurant. Okay, cool. Now it yelled at us because there has many this association has to be between two records or models of that conforms to the table record protocol, and our dish doesn't do that. So just take the table record, move to dish, and just for clarity again, go with extension dish. And we need the other protocols too, so we can just add them as well. Just do a fetchable record and an encodable record. Just close this off and move back. Did I miss? So, oh yeah, of course we need a callable here too. Go with callable, Command B, should compile. You can go back. Okay, now the last protocol is the most crucial one because it determines how it persists data in the database. And there are two protocols to choose from. It's the persistable record or the mutable persistable record. Both of them let us persist data in the database, but mutable persistable record mutates the data on insertion. And they're going to affect some of our design choices, especially the mutating one. But we are going to start off easy with the persistable record. So add an extension to the restaurant, just for clarity again, to persistable record. And I'm going to explain more of what those design choices are going to be, but just follow along and you will see. You can actually do the same thing because we need that for the dish. We are going to persist dish data too in the database, of course. Just do it like this, add the persistable record here. Cool. Now we can finally start creating our more or less our CRUD operations. So not all of them, of course, but we need write operations. So go with mark and you say writes here in the local database. We are going to, of course, extend the local database and add our first method, which is going to be create our restaurant. And since we say create restaurant, it of course makes sense to have an underscore and go with restaurant. And since I promised that we're going to use concurrency, it's going to be asynchronous and it can throw. So go with asynchronous throw. And now take advantage of the writer and say try await writer. And you can see here dot write executes database operations. This one is not that important. But what is actually super important inside the database operation is that database operations are wrapped in a transaction. And that in this case is not that useful because we only have one operation here and it's just the insertion of a single restaurant. But if we had multiple insertions of different data, so like this, let's say that the last piece of data was dependent on this one or something like that. What is cool with a transaction is that if one of them throws, the whole transaction can be rolled back. So let's say this one passes and insert data, but we want to have like 0 or all 3 of them, then this transaction can be rolled back. So if this one is inserted and one of these fails, this one will not be inserted. And that can be super useful if you have, like I said, data dependent on each other, or if you wanted to write all of them or 0. But in our case here, we are only going to insert one restaurant at a time. So just keep it like that. And now we have to do the exact same thing for a dish, and it's going to be, it's going to be the exact same thing. So just go with create dish here, move on to the restaurant, go with dish. Same thing again, move here, and you go with type dish to, of course, you have to make a change here, and it's going to be a dish.insert db. Command B, it should compile. Cool. And if you remember, I also promised that we are going to use combine. So let's start creating our observer. So go a mark, observe. And the same thing again, go with an extension of our local database. And we are going to say func observe restaurants. And since we're using combine, it's of course going to return an any publisher, but I forgot to import combine. So let's go up here, go down, and import combine, and go below here again, and we go with any publisher. And since we are listening to the restaurants, we have to return an array of restaurants, and this one can throw as well, or it has an error. And let's create the observation. So first say let observation is equal to this value observation that we have from GRDB. It has this tracking method. And what this one essentially does is that every time what's inside of this closure, this call, whenever this call changes, the closure will get triggered. So you see here, we are fetching all the restaurants. So whenever something with all the restaurant changes, so whenever, let's say, we have 10 restaurants, when the 11th one is added, this one will get notified, or a restaurant is removed. Any changes to all the restaurant, whenever one of those changes happen, this one will get triggered and we will be notified. And that's starting to sound a lot like a publisher. And that is why we can say let publisher is equal to the observation that we have dot publisher in, since we're reading, of course, in the reader. And we can return that publisher, but it has a horrible type. So let's type erase it. And if you do a command B now, everything should be fine. Let's move along and do the last one, which is going to be, of course, reads. We are going to again extend our local database. And this time we are getting the dishes for a particular restaurant. So this is the more complicated query that we have. So restaurant of type restaurant, and it's going to be asynchronous, and it can throw, and it's going to return an array of dishes. Cool. Now, this is going to be really similar to the writes that we have, but instead we are using the reader.read, which instead execute a database operation, but now it just read only. Okay. Same thing here with the transaction actually, but it isn't that useful now. But let's go here with dishes, and now you can see that we have this predefined request that we can use, because we have the restaurant and we have the .dishes, which is that query interface request, and we can use it to fetch all, and now we can return those dishes to a command B, and it should compile. Awesome. Now we only need to update our view model, and I can see our new methods working. Okay, so let's move on to the first one, and I think the add, it makes sense to add first. So let's do here and add the creation of restaurants, and Swift take care of the ID. Go with the restaurant ID, and it's going to be UUID of type UUID string. Since we had a string here, let's say var restaurant is equal to a restaurant, and it's need an ID, which is the restaurant ID, and we have the restaurant name. And let's go with try, await, and we go with the creation of restaurant. We don't have the database, of course, so we have to do it private let db equal to local database dot shared because of the singleton pattern. Now go with try, await db dot create restaurant of restaurant. And we can, since we are waiting for that one, we can go with the dish one here and go with dish ID. We are not providing the ID. SQLite or GRDB are taking care of it for us. So the only thing we need is the restaurant ID, of course, and the restaurant name. I do a yank here, and I just go one below and go remove U here. Oh, the name is wrong. It should be dish2, and above should be dish1, of course. Command B. And now we have to do the creation of those two, of course. So do a try. Let's be a little bit smart and use concurrency and do them simultaneously and do it. Try, await, and you can go with parentheses, and you do db dot create dish, and you say dish1, and you go with db dot create dish, and you say here dish2. Now you can see some of the design choices that I was talking about, because now here, if the restaurant fails, we're not going to continue with the dishes, of course. But one of the problem here is that if the restaurant succeeds, and dishes fail, we have created a restaurant without a dish, which is sort of fine. It works because it's not that weird. It would be weirder if it was the opposite, of course. So let's move along, but we are actually going to fix that in the second part. But now we need to bind the listening for the restaurant. So go with, is it the restaurants view model? Yes, it is. We have combined, but we don't have the database. So go again with private let db equal to local database dot shared again. And then we go with db. And let's say below here, more combined approach, observe restaurant, and it has an error, so you need to handle that, but it's really simple. Just go with error in, and we can just return a just publisher with an empty array if it fails. And of course, we assign it to our publisher, which is that at published property, which is the restaurants, of course. Command B, that one should be fine. And now we only have the last part, which is from the details. So add, is it the restaurant details view? We're not going to use a view model, just do things very simple here. So go with, let's say the dishes here. You go say dishes here is equal to try. Oh wait, we have to force unwrap here. Don't do this in production, of course. Is equal to the local database dot shared dot get dishes for restaurant, and this details view has a restaurant passed in. So go with that restaurant, and now if we do Command B, everything should be working. We have some complaints here. I should maybe use a let statement instead, just to be more explicit. So go with that here, and same here too. Command B. Those should go away. And now let's do a Command R and see it working. Okay, cool. Now let's add our first restaurant here. I'm going to go with Tell Burger and hope that auto-completion is not going to do something weird here. Okay, good. Tell Burger. This one is going to be Spicy Burger, and this one is going to be a Bacon Burger or whatever. Yeah, let's go with that awesome dish name. Okay, do a creation, and if this works now, we should see a restaurant because we have a listener for all the changes for every restaurant. So there should be a new restaurant now if we pull this away. And if you pull this away, you can see Tell Burger. We tap this one and it fetches the associated dishes for that particular restaurant. Cool, it works like it should. And we have to see the title here too for the restaurant. Awesome. Okay, now for the second part. Now we want to persist data with a mutable persistable record. And like I said, this protocol gives actually some new advantages. But first, since we are going to actually make some changes to our schema, we can actually take advantage of this one here. So I'm actually going to comment this one out because our ID property, it's not going to be a text. It's going to be the same as we have for the dish. So go with here and say table.auto-increment primary key, and it's going to be an ID. And since we do that for the ID, if you remember the auto-incremented primary key, it should be a signed integer of 64 bits. And that's why, let's say this one should belongs to restaurant on delete. Yes, everything here now should, okay, we don't need to change anything here. And this one should be fine too. Okay. So now let's move to the restaurant and update it because we need now the mutable persistable record. And with it comes one special method, and it also makes sense because it is mutating, because we are going to change our data on insertion, and if that doesn't make sense, it will soon. So let's say that the ID here is the inserted dot row ID, and the ID up here too, since we are letting SQLite or GRDB take care of it, it's going to be a signed integer. And we are not taking care of it, so keep it as an optional. Okay, remove that and do a Command B. This one should be fine. And we can actually, if we go back to the dish, we can actually just keep it as we can keep the persistable record here because we are not going to do any mutation for the dish. It's only for the restaurant. Okay, and now we actually just need to make some small changes to make this work. So let's move on to the local database first, because we are now going to do a single write operation instead of having two. So let's move this one. Just remove all of them and just write it out again. And now let's see, we are going to say func and say insert restaurant and dishes, and we are remove that, and we are going to have here, we're going to have that restaurant of type restaurant this time, and we are going to not pass in the dish itself. We're going to do the creation inside that transaction. So just pass in the string name for that dish. So dish1, dish2 is going to be string. And it's, since we use concurrency, asynchronous throws, and not going to return anything. Okay, now go with try, await, writer.write. Same thing again, db in restaurants, db in, not in restaurants, but db, and you say let restaurant is equal to try. And you see now we go with try and we say restaurant dot inserted, not insert, but inserted. And as you see here, it executes the insert statement like we did, but it will, you can, I'm in the way, but what it says is it will return back the inserted record, which means that this data here mutates. And normally, if we wanted to get that ID, we would have to write to the database, then the ID will be set in the database, and then we have to get it back. But as you see now, there's no read operation here. So it mutates on insertion. It's the same data that we had. But now, after we have done this operation here, our restaurant actually has now an ID. Cool. And since we know that this one has an ID, you can actually safely use that ID for our dish. So now let's say dish one, restaurant ID. You can go with the restaurant and you say .id, and you can safely actually do a force unwrap here, and you can go with dish1 for the name, and you do the same thing here. You have dish2. And of course, it's going to be dish2 here. And again, do a try and do a normal insert for dish1 dot insert db, and the same thing here. Go with dish2 dot insert db. This one should be fine. And why it can do, let's see here. You can convert type 64. Oh, we have not changed the dish, of course. This one has to be now assigned integer of 64 bits. Move back. This one should compile now. But what is important here is that when using the mutable persistable protocol, is that to get that insertion to work, to make the data mutate on insertion and actually have an ID, we are dependent on this method right here, which makes sense. You can see it's a mutating func, so it will perform a mutating function on our struct because it's a struct, of course. It can't mutate, but with the mutating function, it can do that. And our ID now is the inserted.row ID, which is from the database. Cool. And that is super useful because if we go back to the local database, if the restaurant let's say the restaurant succeeds, but let's say the dish fail, this whole operation can be rolled back and the restaurant will not be created. That you can see can be super useful, and I think it's actually better design choice in this case compared to the persistable record. Okay, and now we only have to make some changes here. This one will now be a lot simpler. We don't need any ID for the restaurant, of course. So go with the restaurant, and it just should be a name, and it should be our restaurant name. I can just remove the restaurant ID here, and this method too, this one too. It's going to be really simple. And let's go. We only need one method. Yeah, it was only one method for insertion. So try, await, and we go with db.insert restaurant and dishes. We insert that restaurant that we have here. It's going to just be the dish name, and the second one is also just the dish name. Do a command B, and it should compile. What is super important now after we have run the application is to change this one back so we don't keep erasing the database on schema change, but this one should be fine. I hope it doesn't fail. Let's run it and see. Okay, do an add here, and now let's go with, I go with tell. I go with the tell pizza this time. And this one, let's be super creative and go with spicy and bacon again. And if this works now, it should not throw an error. Let's see. We have tell pizza. And you see the tell burger was removed because we, like I said, we erased database on schema change. We had to do that because we changed our schema. We tap the tell pizza here. We have spicy and bacon, and you can see it works. Awesome. Now just remove this to back so you don't have any problems. Just try and run this one again. And let's add back the restaurant that we had, which was the tell burger. So go here and you can add, let's say, tell burger. Let's go with again spicy. The simulator is super slow, but it should be all right. Spicy bacon and go with tell burger. Remove this one and you can see it updates with both them. It's also worth notifying that I forgot to change this one. We should actually, when we changed our schema, it will make more sense to add a version 2. But just keep it now. And there is one more bonus point that I want to make. And that is, if you go to the local database, before we round off here, is that you can actually take this even further. You can actually advantage of the in-out parameter here. And with the in-out parameter, since we are, so I think we're passing the reference, we can actually say that the restaurant is equal to this closure here. And since this closure will return the result after it's finished executing, you can actually return the restaurant in here. And we will actually get that mutated restaurant. So we will get the ID all the way back to our view model if we do that. Like I said, in-out parameter here, restaurant is equal to disclosure and return that restaurant. And of course, it's important that you have this inserted, of course. If you want to see more of that, please go to the documentation. The repository also have really good demo applications, so please see that too. Other than that, I hope you enjoyed this video. Please hit like and subscribe, and I'll see you next time.